Okay, so the next section we are going to deal with is the atomic structure. Atomic structure. The atomic structure of materials determine their electrical properties, as we have seen earlier. The atomic structure of material determines how they behave to free flow of electrons. So that is why we need to know the atomic structure. Atoms are composed of a nucleus and are usually surrounded by one or more electrons. Of a nucleus and are usually surrounded by one or more electrons. Okay? You have an atom, for instance, like this. You have a nucleus. And then we have orbits where electrons are. Either one or more. Either one or more. Okay. Alright. So the presence of electrons presence of electron is what determine the unique properties of various materials. Electrons are negatively charged and the nucleus is positively charged. So there's a kind of force of attraction between the nucleus and the electrons. Okay. So the nucleus also contains materials called proton and neutron. Neutron is a neutral in charge, but proton is positively charged. Electron is negatively charged, and so there's a kind of force of attraction between the nucleus and the electrons. And the farther an electron is from the nucleus, the lower the force of attraction between that electron and the nucleus. And so the outermost shell electron has the weakest bonding, or has the weakest force of attraction between itself and the nucleus. And so that is why the outermost electron that are farther away can easily break away, especially in materials such as metal, and form free electrons that convey free flow of electricity. So the manner in which the outermost electron is held to the nucleus determines the type of material that we have, whether it's conductor, a semiconductor, or insulator, like we have explained earlier. So the structure of atom is important in determining the class of material in nature, whether conductors, semiconductors, or insulators. So the manner in which the electron is bound to the nucleus determines the type of material we have, whether it is a conductor, a semiconductor, or an insulator. Alright. So now we want to look at the atomic structure of few elements that are of interest in electronics. So we have atomic structure of few elements that are of interest in electronics, such as silicon, germanium, boron, aluminium. So those are some of the materials or elements that are of interest in electronics. Okay, so we briefly look at the electronic configuration of some of these elements. Okay, for instance, silicon. The electronic configuration of silicon, which is Si, can be given as the atomic number, silicon atomic number, Si atomic number is 14 electrons. So then the electronic configuration is Si 1s2 2s2, 2p6, 2p6, 3s2, and then 3p2. So these are the electronic configuration of a silicon atom. So you can see that this 14 we have 2, okay, 2 plus 2 plus 6 plus 2 plus 2. Those are the total number of electrons, and we have 14. That is a silicon atom. We have 14. All right. For germanium, germanium has 32 electrons. So germanium atomic number is 32. 32. And the electronic configuration is 1s2, okay, 2s2, 2s2, 2p6, 2p6, okay, 3s2, 3p6, then 3d10, 3d10, then we have 4s2 and 4p2, 4s2 and then 4p2. So that gives a total of 32 electrons. 2 plus 2 plus 6, 10, plus 2 plus 6, 18, plus 10, that's 28, plus 2, 30, plus 2, 32. That is for germanium. That is for germanium. Now for group 5 elements such as boron, that is of interest to us. Let's look at boron. These elements are of interest to us, though not group 4 elements, not a semiconductor. These are semiconductor, the most important semiconductors, silicon and germanium. We're interested in the electronic configuration because they form the major parts of electronics. Boron, on the other hand, is not semiconductor, but it's a kind of material used in doping semiconductors. One major impurity element used in doping semiconductor to achieve good electrical properties of semiconductors. So we are interested in its own electronic configuration. Boron, number of atoms in boron is 5. And the electronic configuration is 1s2, 2s2, and then 2p1. That is for boron, 5 electrons. Also, we are also interested in aluminium. Aluminium is group 3 element, it's a metal that is also used in doping semiconductors. So we are going to talk about doping in subsequent lecture. So please watch out on this channel for lecture on doping. Alright, aluminium has 13 number of electrons. Aluminium, number of electron is 13. And the electronic configuration is 1s2, then 2s2, then 2p6, 2s2, 2p6, 3s2, then 3p1. We have 13. 2 plus 2 plus 6, 10, plus 2, 12, plus 1, 13. So the power of the letters, they are the electrons. While the 1s, 2s, 2p, 3s, and so on and so forth, they are the orbitals. They are shells on which electrons exist on the atom. So that is the electronic configuration of the important elements on the periodic table that are of interest to us in electronics. So we have silicon, we have germanium, we have boron, we have aluminium. So these are their electronic configuration. Okay, so if you are, that is how we come to the conclusion of this lecture, the first lecture in electronics. If you are new, please subscribe to the channel if you are here to do so. And if you are a returning subscriber, don't forget to like and share this video and make your comments down so that I can respond to your comments. Don't forget to also hit the notification bell in order to be notified when we upload new videos like this. Until another class, bye bye.